Hello, my dear students. Welcome to the session. Now, let us look at certain important concept again, because last session we have discussed the power supplied or absorbed by the energy sources. Yes or no? Okay. So, I think we had discussed several examples here. I think almost 7 examples were discussed, and we clearly understood how to really determine, okay, whether the particular source is supplying the power or absorbing the power. Okay. Well, now let us look at another important concept, transformation, because you're getting good number of problems in the exam. Transformation, okay? Transformation. Put the heading, transformation. You have two types of transformations, right? The first one is source transformation. The second one is star delta transformation. Okay, so first we start our discussion with the source transformation. So please write down the source transformation here. The first one, source transformation. According to source transformation, please write down. According to source transformation, a voltage source with a series resistor can be transformed into, please write down that point. A voltage source with a series resistor can be transformed into a current source with a parallel resistor, and vice versa. According to source transformation, a voltage source with a series resistor can be transformed into a current source with a parallel resistor, and vice versa. Okay, but look at this. A voltage source with a series resistor is nothing but what? A practical voltage source, yes or no? And what is a current source with a parallel resistor? Is it not a practical current source? Therefore, the statement of the source transformation can also be given like this. Write down, or you can put or and write down. A practical voltage source can be transformed into a practical voltage source can be transformed into a practical voltage source can be transformed into a practical current source, and vice versa. Yes or no? So please note down this. And you know that I is equal to V by R. Okay? I is equal to V by R. A current source with a parallel resistor is also transformed. Please note down this quickly. This you already studied, I think. You already know it. Just quickly note down. Please note down. Hope you have noted down this, all of you. Now look at this. Why actually this I is equal to V by R? And why V is equal to IR? That is also a question. Okay? Why it is actually like that? I is equal to V by R and V is equal to IR. Don't say that I is equal to V by R is Ohm's law. We already know that. V is equal to IR. We know that Ohm's law, no doubt. But how you are getting when current source value is I is equal to V by R when you go for the transformation? See, you have to understand one important concept here. This concept is also very important in the exam. Okay, equivalent circuit concept. Okay, what is it, equivalent circuit concept? I'm just writing here note. Equivalent. Equivalent circuit concept. What is equivalent circuit concept? Two circuits are said to be equivalent. When? When do you say the given two circuits are equivalent? Okay, what is the criteria? What is the condition? Okay, that's very important because in the exam, whether it is GATE or IES or PSU, I have seen several questions and I am also going to discuss the question based on this concept again, which were asked in the previous GATE or previous IES. He is giving two circuits and is saying that the following two circuits are equivalent. Then what is the value of I in a particular place? In a circuit B, in circuit A, he will give a data completely. In circuit B, he will ask you what is I. On what basis you are supposed to find? The condition mentioned that these two are equivalent. Understand? He will also mention that the following two circuits are equivalent. Then what is the value of capital R? Some resistor value is, is supposed to be determined. I think you understand now. The equivalent circuit concept is very, very important here. But remember, the two circuits which are given, they might be active or they might be passive. Yes or no? The two cases again you will see. You cannot say one active network, one passive network and say that these two are equivalent. It's not possible. What is an active network? What are the elements that they present in the active network? Tell me. Active network consists of at least one active element and all remaining might be anything, passive elements. Or else it may have all active elements. But at least one element is an active element. You understand? What about the passive element? Passive network? The passive network contains only passive elements. You understand? Okay. Therefore, in the exam, when he is saying that the following two circuits are equivalent, either he will give two active networks or he will give two passive networks. He won't give you one active, one passive. Clear? Now, let us take one particular case, case 1. Case 1. Network X, okay, is equivalent of network X or network 1, let us say. Network 1 is equivalent of network 2. First network and second network. These two are equivalent. Sir, what are these AB terminals? The AB terminals are the load terminals or reference terminals, we can say. Okay. Whenever he is asking the question, the following two networks are equivalent, he will clearly mention what are the terminals. With respect to which terminals they are equivalent is supposed to be mentioned in the question itself. You understand? See, I will say one thing, that two persons are equivalent. Two persons are equivalent with respect to what? With respect to dress appearance or color or character or behavior or attitude. Definitely some particular point must be taken. With respect to what you are telling, that these two persons are equivalent. Similarly, the two networks are equivalent with respect to which terminals they are equivalent. Therefore, definitely he will mention the terminals AB or XY, something like that. Now, look at this. Network 1 is an equivalent of network 2 with respect to what? Two terminals, AB terminals here. Clear? Okay. Now, the two networks N1 and N2 are active. What is the first case actually here? The first case is what? N1 and N2 are active networks. Now, N1 and N2 are active networks and these two are said to be equivalent. Okay. They are equivalent if and only if the current I1, the voltage V1, let us say, the current I2, the voltage V2, let us say. You understand? Okay. If I1 is equal to I2 with respect to AB terminals, and not or, no exemption, not any one of them, and V1 is equal to V2, then N1 network 1 and network 2 are said to be equivalent. Hope you understand the point. Okay, you have to now check with respect to the given terminals, find the current in the first network, find the current in the second network. Are they equal? Yes, but this is not over. The story is not over yet. Again, find V1 in the first case and V2 in the second case. Then are they equal? I1 is equal to I2, then V1 is equal to V2, when both are equal, then definitely we can say that network 1 is an equivalent of network 2. Understand here? Okay. Now, these two are active networks or passive networks? Definitely active networks because there is an active element. Now, with respect to AB, you can check whether current and voltage are same or not. Now, what are you trying to do here? You are trying to construct an equivalent of this. Network 2 is an equivalent of network 1. In the transformation, what are you trying to do actually in the transformation? You are transforming, and you are transforming. After transformation, the resulting network is the equivalent of the given network. You are transforming, the resulting network is an equivalent of the given network. The resulting network is an equivalent of the given network. You got the point? Okay. Now see, these two are equivalent according to this concept. Yes or no? After transformation, you are getting equivalent, right? Let us find the current. What is this actually here? Because it is not closed, therefore definitely you can get 0. Since 0, there is no drop. The total voltage, how much you are getting here? V. Now, are you getting the same thing here? You must get now, because now here, see, with respect to AB, what is the current here? 0 ampere. What is the voltage that you are getting here? I into R, but you are supposed to get V. That is why, if I is equal to V by R into R, that voltage will become what? V. Now you see, 0 ampere, V and V both are same. Therefore, network 2 is the equivalent of network 1. I think you understand why we are taking I is equal to V by R. In order to construct the equivalent of the given network. That's it. Similarly, here also, what is the current? 0. Here, 0 ampere is flowing. What is the voltage? The entire current is passing here. Definitely, I can say I into R. Yes or no? Now, coming to here, what is the current? 0 ampere. What is the voltage? V. Now, to get IR, this V must be equal to IR. Therefore, IR. See, current and voltage both are same. You understand, all of you? So, this is what equivalent circuit concept I am telling you. This is very, very important. Okay, in exam point of view also, okay, is giving literally two networks and giving a statement that the given networks are equivalent. Then find I, find R, find V, find X. Like that he may ask you any question. But the concept is same, I am telling you. Okay. Now, another case. What is the another case here? Case 2. What is the case 2? Case 2 is N1 and N2 are passive. If N1 and N2 are passive, N1 and N2 are passive. Okay, look at this. I'll give you sufficient time. Please look at this first. N1 and N2 are passive. In case of passive networks, find RAB in this case of first one and RAB of second network, that is RAB. Better you take RAB1 and RAB2. If RAB1 is equal to RAB2, then okay, N1 and N2 are said to be equivalent. If N1, if RAB1 and RAB2 is equal to, okay, or both are equivalent, let us say both are equal, then I can say N1 and N2 are said to be equivalent. So it's very clear, active networks and passive networks case. So please note down quickly. Please note down, I'll give you time. Please note down. For solving the problems, I would like to ask you a simple question that, can we apply source transformation to a dependent source problem? Can we apply dependent source problem? Note. For a dependent source problem, okay, can we apply? For example, you have a network like from 3 Vx, let us say. This is the dependent source. Say this dependent variable is shown here. That means this is the voltage. The Vx is the voltage across R1, and upon this Vx, this dependent source is depending. Clear? Can we apply source transformation to these particular cases? Is it possible? Remember, in case of dependent source problems, you can apply source transformation with certain conditions or precautions. What is that condition? Look at this. This R1 is a resistor which is in series with the voltage source, and it is also involving in the source transformation. A voltage source with a series resistor can be transformed into what? A current source with a parallel resistor. Now, this R2 and R3 are not directly involving the source transformation, but R1 is involving the source transformation, whereas this dependent variable is related to R1, related to the resistor, which is involving in the transformation. You understand? In such cases, the source transformation may not be possible. Okay, I repeat once again. If the dependent variable is related to the resistor which is involving in the transformation, then the source transformation won't be possible. Okay, source transformation is not possible for this particular case. But if I take something like this, this Vx is shown here now. Okay. Now there is no problem because this voltage source and the resistor doesn't have any variable here. Okay. Now this variable is related to the resistor which is not involving in the transformation. There is absolutely no problem. This transformation can be done without any hesitation. So therefore, source transformation is possible. Understand all of you? Source transformation, when you apply to a dependent source, you must take care of this particular point. Therefore, you please write down here. In case of dependent source problems, in case of dependent source problems, please write down. The source transformation is possible. The source transformation is possible if and only if the dependent variable is not related. The dependent variable is not related to the resistor which is involving in the transformation. which is involving in the transformation. Please note down these two cases. Please note down those two cases. I repeat the statement. In case of dependent source problems, source transformation is possible if and only if the dependent variable is not related to the resistor which is involving in the transformation. Please note down these two cases and mark it that source transformation is not possible, whereas here it is possible. Again, examples. First example. That is over, okay? Find Vx using source transformation. See, you can find Vx using any method. There are so many methods, okay? But what is my intention here? To experience the source transformation. I hope you understand the point. Okay? Find Vx using source transformation. So let us find. What will you do? Make an attempt. All of you, first you note down that circuit and try to make an attempt. Okay? Now, a current source parallel resistor can be transformed into voltage source. But if you do this transformation, there is no use. The circuit won't become simple. It becomes again complicated. But this voltage source and this resistor are in series. If you transform these two into a current source, the resulting equivalent network, now that looks parallel to all these elements. Yes or no? Okay, agree all of you? Therefore, 48 by 12. What is that 48 by 12? And what is the direction of current? The direction of current is, you must be very careful. It is plus, right? Towards the plus, actually it must be located. And 48 by 12 is 4 ampere. Okay? Now, the resistor is parallel. Already there was one more resistor parallel. And there was a current source. Okay? And this is a resistor. There is another resistor. 2 ohm and 1 ohm. And you want minus plus Vx. This is 4 ampere. This is minus 2 ampere. This is 12 ohm. This is 6 ohm. These two are in parallel. And these two are in parallel. These two current sources can be replaced by a single equivalent current source. But 4 amperes up, minus 2 amperes down. 4 minus of minus 2. That is 6 ampere. Okay? Therefore 6 amperes. Now you can show upward. Because 4 is dominating. 4 minus of minus 2. And you have, okay, 12 parallel 6. 12 parallel 6 will become 4 ohm. Okay, and you have got now, this is 2 ohm and this is 1 ohm. And you are expected to find this is Vx. So what is the current actually here? 6 amperes is getting divided into these two paths. The one path is having 4 ohm. The other path is having what? 3 ohm. Okay. You have to divide for 3 and 4. Some people may do mistake. That is 2 and 4 they divide. Actually 2 and 4, how they are connected? They are neither series nor parallel. Yes or no? 2 and 1 are in series. That result is parallel with 4. Actually 2 and 4 are neither series nor parallel. 1 and 4 neither series nor parallel. But 1 plus 2, 3 is parallel to 4. Then you have to apply the formula for this. If you take Ix here, the Ix can be determined as taking this one as a single element, that is 3 ohm, opposite resistance 4 by 4 plus 3 into, what is this? 6. That means, what do you get here? 24 by 7 ampere. Okay. Now, this same current is passing through 1 ohm and you are expected to find Vx here. Now, Vx is equal to this 24 by 7 into 1. Okay. But look at this. This particular element, whatever you are finding the voltage, look at this. What is the current actually flowing here? It is flowing Ix in the downward direction. Because of this current, what are the polarities that you are getting? Plus minus. We call these polarities as actual polarities. These actual polarities are determined based on the direction of current flowing through this 1 ohm. Actual current will decide actual polarities. But you want the voltage with the different polarities. That means you are connecting the voltmeter, instead of plus minus, you are connecting what? Reverse. Yes or no? So when you read the voltage, I think most of you might have experienced in the lab, when you connect the voltmeter with plus minus, let us say if it is reading 10 volts, if you reverse and connect it, it will definitely read minus 10 volts. Yes or no? Therefore, what is happening? You are now finding the voltage with the reverse polarities Vx. This is the actual polarities, desired polarities. I repeat, actual polarities, desired polarities. Desired polarities are not matching with actual polarities, therefore you will get a negative sign. So what is the value? Minus 24 by 7 volts. This is your answer. Please note down. Please note down. Now, second example. Now, can we transform this particular network? If we are able to transform this particular network, then what could be the resulting equivalent? Similarly, there is another network. Can we transform this network? But there are two networks we would like to transform. Is it really possible to transform? Okay. To transform, how the network should be, how the elements must be connected. In case of voltage source, the voltage source with a series resistor can be transformed into a current source. Or as a current source with a parallel resistor can be transformed into a voltage source with a series resistor. Yes or no? Clear? But what is happening here? It is having a voltage source with a parallel resistor. It is having a current source with a series resistor. Can we really transform? Can we really transform? Yes, think about it. These two networks you can easily observe. See, we can transform because there is one more element. And one more thing, these two are parallel. We already learnt one more concept, that any element parallel to an ideal voltage source, that can be neglected or not. Understand? Any element parallel to an ideal voltage source, that can be neglected or not. Yes, that can be neglected. Therefore, if you neglect this, and you can neglect this as far as load terminals are concerned, in the last session we made it very clear. We had a lot of discussion. Okay? And that with respect to load terminals, we can neglect any element parallel to an ideal voltage source. If we neglect this voltage source is coming in series with what 4, then I am now comfortably going for the transformation after neglecting that. Now this is what actually the equivalent I am getting. This is A and this is B. This 4 will come here and this source value will become 12 by 4. 12 by 4. This is 3 ampere. You understand, all of you? Okay. Now coming to this. Any element in series with an ideal current source can be neglected or not? Neglected. If this is neglected, then how these two elements are coming like? These two elements look like what? Parallel combination. Now the current source parallel to, okay, the current source with a parallel resistor can be transformed to what? The voltage source with a series resistor. But now, since the current direction is downward, you must take minus and plus. Yes or no? Now the resistor remain resistor here. What is this? This is 10 ohm. And what is this value? 3 into 10. 3 into 10. That is 30 volts. Yes or no? Okay. This is how you can really solve. Okay. Now, note down. All of you please note down quickly. Then we will switch over to star delta transformation. So the second important concept is, okay, star delta transformation. In this, again, the first one will deal with delta to star, then we deal with star to delta. Okay, first we deal with delta to star. So please note down that quickly. Meanwhile, I'm just drawing here. In case of delta to star, you're trying to construct, after transformation, the resulting network is what actually? The resulting network is an equivalent of the given network. Sir, after transformation, what are you getting? You're getting an equivalent. So when do you say the networks are equivalent? Tell me. Just now we have discussed the two networks are said to be equivalent. Again, you must see different cases, whether the given networks are active networks or passive networks. Now in the previous case, source transformation, we have seen two active networks, but these two networks are passive networks. Now, I want to find RA, RB, RC in terms of RAB, RBC, RCA. RAB, RC, RBC and RC are known values. RA, RB, RC are unknown values. Unknown values are expressed in terms of known values. Is it clear? Now, I would like to find these three. Means there are three unknowns. That means there are three equations we require, three conditions we require. What are those three conditions? On what basis you are deriving? These three conditions can be derived based on the equivalent circuit concept. What is the equivalent circuit concept? Two networks are said to be equivalent. Passive now, second case. We have seen, second case, passive. Now, in case of passive network, what is the criteria? If both the networks are offering resistance same, then we can say equivalent. But we have seen only two terminal network, but here three terminals are available. For a star or delta, you have A, B, C, not simply AB. But in such cases, these two networks are said to be equivalent if find RAB here and RAB here. They must be same. Find RBC here and RBC here. They must be same. Find RCA and RCA. Both must be same. That means RAB in both the cases, RBC and RCA in both the networks, if they are equivalent, then two networks are said to be equivalent. That's it. So these three conditions we can take now. Now RAB first, let me take here. RAB, capital AB Nana. So you are looking into the network through what? These two terminals. When you look into the network through AB terminals, when you see through the network like this, these two elements look like series, then it is becoming what? Parallel. Therefore, RBC plus RCA, okay, in series with, these two are in series and the result is parallel with what? RAB. It must be equal to RAB in this case. Now what is RAB in this case? Tell me. When you look into the network, this is completely isolated. This is floating in the air. There is no written path. As far as AB terminals are concerned, then these two looking like what? In series. Therefore, RA plus RB. This is the first equation. How many equations you want? There are three unknowns, three conditions required, three equations required. So RBC. RBC, when you look like this again, these two series then parallel. So RCA plus RAB parallel with RBC is equal to now RB plus RC. RCA, okay? RCA. Now when you look at the network, these two are in series, the result is parallel to RCA. So RAB plus RBC, it is parallel to what? RCA, therefore is equal to RC plus RA. Three equations, three unknowns. We can solve them. You can solve them, and I'll give you directly formula after solving equation 1, 2, 3. I'll give you directly that formula, okay? Look at this, solving 1, 2, 3. Solving 1, 2, 3. What do you get? RA is equal to RAB into RCA by RAB plus RBC plus RCA. RB is equal to RAB into RBC. Denominator is same again. RC is equal to RCA into RBC by the denominator is same. You understand? Now, the same formulas can be expressed in terms of conductance, because tomorrow you may be dealing with capacitors. I told you already that resistor formulas, inductor formulas are same. Conductance formulas and capacitor formulas are same. They look same. Okay? So, in the reduction of the networks, whether it is a star delta transformation or series parallel combination, you can have a flexibility if you know the formulas in terms of even conductance. Okay? Now, GA will become actually 1 by GA, 1 by GAB, 1 by GCA and so on, and simplify that. After simplifying that, the GA will become GAB into GBC plus GBC into GCA plus, okay, GCA into delta to star, okay, GCA into GAB by, okay, GA, right, you can say GBC. GB is equal to, numerator same, but denominator will become now GCA. GC is equal to, numerator is same, now this becomes GAB. You understand? Okay. Now, all these formulas, you can note down clearly here. Quickly you can note down, and then we can see even star to delta also. Note down quickly. So, the star elements are known values and delta elements are unknown values, A, B. This is RA, this is RB, and this is RC. And now you are actually dealing with what? Okay? Same equations, but reverse you are supposed to write. RA plus RB is equal to, this is supposed to be here and all those things, okay? Now, the same equations I am taking here, but I am going to actually solve those equations and finally I am writing the formulas here. Please note down, okay? Please note down the formulas directly. Now, RAB can be written as RA RB plus RB RC plus RC RA by, please write down here along with me, all of you, please write down RC. RBC, numerator is same, RA. RCA, numerator is same, RB. Similarly for conductances, GAB can be written as GA into GB by. I think all of you understand how I am getting this, right? Reciprocal of each and everything I am taking here. GA plus GB plus GC. GBC, GB into GC by GA plus GB plus GC. GCA is equal to GC into GA by GA plus GB plus GC. Like this you can note down. Okay, these are the formulas you have to remember and you can